Hi everyone, thank you GDG Ludhiana for inviting me. Today I will talk about state restoration of Flutter app. My name is Karol Wrótniak, I live in Poland in Central Europe. I work as mobile developer at the local software house. I do native Android and Flutter applications, and I am also a lead of local GDG chapter. Maybe let's start with a simple demo. I have a very simple app here. It allows me to add to-dos. Here are list of those to-dos. Each to-do item has a title and a due date. Let's add maybe another one and start adding yet another. Set some date, or maybe not set. But now I decided to check the GDG Ludhiana past events. Open the Chrome app, web browser, and I checked the speakers in the latest DevFest. And then I decided to go back to my app. Here it looks, on the recents it looks nice. However, something strange happened. Everything is lost. App is working, but the state is lost. If I go back to Chrome, see it reloaded, but the state has been restored. Scroll to the place I was when I left. Why that happened? This is kind of feature of mobile operating systems, because on mobile you have limited resources. Mainly we are talking about memory, RAM. On PCs, MacBooks, you have a lot of RAM, usually more than on the average mobile smartphone or tablet, and you have also swap, which allows to store the unused pages on the hard drive. But on mobile devices you don't have a swap, you have a lesser RAM, and if there is no memory to load a new app, system can kill some app in the background to make the space. But to not distract the users, to not broke the user experience, system can save the state of the app. As you can see, in case of Chrome, the state was the latest loaded website and the scroll position. In case of the to-do app, the state was the navigation stack, the list of dialog windows which I opened, all the data I entered. And in Flutter apps, this state restoration is not enabled by default. You have to enable it and write some code to make it work. So let's check how to do that. First of all, we need to figure out what is our restorable state. It will be connected with widgets holding some in-memory state. For example, the checkboxes, radio buttons, text fields, everything you can click, you can type something, you can collapse, expand or scroll. Everything like that contains some state. But two important things to know. This has to be in memory state. So for example, if you listen to every checkbox change and write the new value immediately to the shared preferences or the local database, there is no volatile in-memory state. There is nothing to lose because everything is saved persistently immediately. Similarly, if you have some purely decorative UI state, for example the inkwell effect, we don't need to save the percentage of inkwell to restore it. It's purely decorative. And also in case of pickers like date pickers, time pickers, photo pickers from gallery, not only picker itself has a state, but the picked photo, picked item, until it is saved or used somehow, it is also a state. Okay, so let's maybe, and one important thing, the navigation history is also a state. Yeah, let's check how to enable the state restoration in Flutter app. In the Dart code, you need to add the restoration scope ID here, and it has to be any non-null string. And also one step additional on iOS, you have to add the restoration ID to the Flutter view controller. And adding the restoration ID won't enable out of the box this restoration on each widget. We need to explicitly tell what is the state and how it should be restored. To do that, you need to add a RestorationMixin to the state, holding the mutable in-memory data. Keep in mind that this state is not necessarily located in the widget you are clicking, you are touching. For example, checkbox itself can be stateless, and the state can be held in its parent. In this case, the RestorationMixin should be added to its parent. Okay, what we have here. This mixin has two methods which we have to override. First one is restoration ID. It has to be any non-null string, and it has to be unique across the app. Usually it should be something like page name. And we also need to override the restore state method. Here we register the restorable properties, which I will cover in the next slides. In this simple app, each to-do item has a title and date. So in the code we probably have something like text editing controller, which allows us to extract the text, and view date. The date comes from picker. We use the controller like this in some text field. To make those things restorable, we need to change the plain fields, plain properties to restorable variants. Flutter already ship some commonly used restorable variants of fields. For example, you have restorable text editing controller, restorable datetime, restorable int, restorable booleans, and so on. What is important, those restorable values, restorable classes, don't extend from their underlying variants. So the restorable text editing controller is not a subclass of text editing controller. You cannot use it directly. You have to extract the value from the restorable field. And what is important, and which I suggest to do right after adding the fields, is to dispose them. Everything restorable field has to be disposed in widget dispose method. And we need to register them for restoration in the restore state method. The second argument here is a key, and it has to be unique across in the scope of this page, not globally in the whole app. Sometimes there is no ready-to-use Restorable class, and we have to implement it ourselves. Let's analyze this example of the scroll position. As you remember, in the Chrome app, the scroll position was restored. To do that in Flutter, we cannot use the Restorable scroll controller. There is no such class. So we have to use the simple usual scroll controller and add the Restorable double for the scroll offset. And similarly as before, you have to dispose it, register it for restoration. If you haven't used controller before, for example, because you don't need to scroll it programmatically, you need to add that controller to the scroll view. And two important things. We need to somehow make this scroll offset, Restorable scroll offset, up to date, so it always holds a current scroll value. To do that, we add a listener to scroll controller, and on each scroll change, this callback is fired. We take the current offset from scroll controller and assign it to the scroll offset, the scroll Restorable double. And we need also somehow restore this, somehow pass this restored value from this Restorable double to the UI, to the widget. To do that, we add a post frame callback. This callback is fired once, the init state method, and after that we pass the current value of scroll offset to the scroll controller. Okay, let's maybe jump to another slide. This is more complicated than previous one. We have item class for the to do item. It looks like this, pretty simple. And we have a list of those items. First step is to make this class serializable. Here we are using the JSON, but it's not necessarily. You should use JSON. It can be any primitive type. Primitive, I mean, for example, string, double, int, null, list of those objects, everything like that is primitive. If you are familiar with method channels, there are the same constraints here, so we can only pass the primitive data over the channel. So similarly, you can use only primitive data to pass to the restoration engine. So in this case, I'm passing title as a string and datetime as a Unix timestamp in milliseconds since epoch. And to make a custom restorable property, we need to extend from a restorable value. This is a generic type. And here we put a type of our class. And we have four methods, from primitives and to primitives, like for serialization and deserialization respectively. So in case of converting two primitive values, we simply map each element to the string JSON representation, and we have a list of string as the output. And oppositely, in the from primitives method, we map each string to JSON, make a to-do item out of this JSON, and collect all the items to the list. Now, there are also two more methods. Create default value, as the name suggests, returns the default value when there is no restoration data. For example, when user enters the screen first time. Did update value may not be obvious. here I am just unconditionally notify the listener, so I am, let's say, accepting this value. But if you, for example, have some properties in this to-do item class which are not part of this JSON representation, this primitive representation, you may compare this old value with current value and decide to not notify listeners if change consists of only items, only properties which do not contribute to this primitive representation, but usually we just call this notify listeners unconditionally. Okay, and how to use it? If there is non-restorable property, it's a simple list. If we make a widget or make a list of items on the UI, we just map it to map list of to-dos to list of widgets. And if item is added, we just modify that list. In case of restorable item list, we need to change the type. And as I said before, this restorable to-do item list is not a subtype of list, so we need to extract value from it. We need to dispose and register for restoration as well. And here is an important change which may not be obvious. We cannot add item to the underlying list. I mean, we can write the code to todos.value.add and it will compile. There will be no exception at runtime even, but it won't work. It won't work because if we don't set the value here, this method will not fire, and this change will be ignored. So remember to not mutate this value, but assign a new value to the restorable property. So in case of this app, if we need to add an item to the end of the list, we just make a new list with all the previous values and this item appended. Okay, let's jump to the restorable roots. Let's begin from the transition after tapping a floating action button plus. In that case, we have to display the dialog with text field and date picker entry. And there is no input, there is no argument, but there is a return value. So if user clicks on add button, the to-do item is returned and we can add it to the list. In case of non-restorable versions, it's pretty simple. Just call the show dialog, await for item. If it is not null, we add item to the list. It can be null if user dismisses the dialog without pressing the add button, for example, using the back button on Android or touching outside the dialog onto the backdrop. Okay, how to do that in the restorable way? We need to add the restorable root future, and this is generic type. We return the nullable to the item, null if the dialog is dismissed, and this root future has two callbacks. On present is fired on each navigation forward when we open the dialog, and on complete is fired when we return from the dialog when the result is returned. Here in on present we have to return the restorable push. Here we pass the static root builder, which will be covered on the next slide. And on complete, nothing special. No, we just check if item is not null. If so, we append item to the list. So it's the restorable version of the to-do item list. And let's analyze this root builder. It has to be static. It is very important. It has to be static. If it is not static, you will get an error. And here nothing special. Just create a dialog root to the add item page, which contains the UI for the dialog. And for usage is simple. In the onPressed callback of floating action button, we call the present method. Here is a tear-off, and as usual, we need to dispose this root feature as any other restorable property. Okay, maybe let's jump to the more advanced case. If you remember, there was a second dialog, the system date picker, which allows us to pick the date for to-do item. This transition, this navigation from the item adding dialog to the date picker has not only the result but also an argument. So the picker returns the selected date, or null if nothing is selected, but it also takes an initial date as an argument. Non-restorable version is very simple, so call show date picker plus initial date, or its current date or previously selected date. There are some other parameters, but they are not important here. They are skipped for readability. And how to do that? We have also to use the restorable or root feature. Type here is a date time, not item, because the date picker refers only date time. We have also the onPresent and onComplete method. OnComplete is analogous. So if item is not null, we have to react somehow. Here we just update the new due date. And there is a root builder, which we'll cover on the next slide. And here is an argument. The argument has to be primitive type. Date time is not a primitive, so we convert it to the Unix timestamp, the milliseconds since Unix epoch start. And so if here we serialize the date time, we have also to deserialize it on the other end, and the other end is in the builder. So here the builder is more complex. This initial date is taking the arguments as integer and creates a date time out of it. Important thing is this restoration ID. Date picker dialog comes from framework. We don't have this dialog in our application code, so we cannot add the RestorationMixin to the date picker dialog, but we can pass the restoration ID here. Okay, so let's check how to test it. On the previous demo, it just worked, but it won't always. Not every device will just behave like this. To do that normally, let's say naturally, you have to fill all the memory, which may be not convenient and not reproducible, but fortunately there is a setting in developer options in Android, which is called don't keep activities. If it is enabled, then let's go to the app. As you can see, it has been restored, and one important thing is that you have to go to another app, not only put this up to the recents. Let's say if I go back here, so on, it is not restored, but if I open any other app and go back to Chrome, it is restored. And what is also important, you should disable it if you don't need it anymore. If it is kept enabled, then every app will start from scratch. It will take more time, it will drain the battery, but if app does not implement state restoration, you can lose your data. And if app is written with bugs, it has bugs, then it maybe not implement this state restoration properly, it may crash, which is common in native Android app. In case of most of all the Flutter apps, we just lose the data. Okay, maybe let's jump to iOS. It is maybe not much, but more complicated than Android. Here you need to open the Xcode, start the app from the Xcode, and it succeeded. Let's wait for app to start. Let's make some state. And here you have to put the app to the background. And press tab in Xcode and open the app. As you can see, the state has been lost. Okay, let's go back to the slides. Yeah, and what is important for both Android and iOS, you should not use the hot reload and hot restart when testing the state restoration, because the app needs to be started from scratch. In case of using Xcode, there is even no hot reload and hot restart, but if you are testing on Android, remember to not use those way to restart the app. Okay, I think that's all from my side. If you are interested in that topic, you can read my article. It's an article on Codeco. It has this also the code, the same app which I just showed you, and quite comprehensive guide is in the Flutter official Flutter docs. You can start with the Restoration Manager Flutter docs, and if you need to find me, you can do that on via the email, on GitHub, LinkedIn, even Mastodon. If you have any feedback, you can also use this anonymous survey. And thank you for watching, and see you next time.